And I will explain about introduction parts and next customer requirement parts. Okay, for the first part, introductions, these are the backgrounds. First, natural rubber, or scientifically known as Hevia brasiliensis, was introduced to Malaya. Okay, today area under rubber grew quickly and never looked back. And the rubber itself has also been found useful in the industry, but not many studies are done on the rubber seed itself. Okay, next I will move on the objective of this project. First is to study the process of extraction of seed oil using Softlex extraction methods. Next is to study the effects of different sodium hydroxide concentration during constant pressure and rotations. Next is to study the effects of different pressure at constant sodium hydroxide concentration and rotation. And lastly, to study the effects of different rotation at constant sodium hydroxide concentration and pressure. So these are our scopes of this project. The scope of this project is mainly focusing on lab industry, because rotary evaporator are mainly not available in chemical plants. So this machine is used to test the sample from plant for the efficient and gentle removal of solvent by evaporation. Okay, now I will be explain about customer requirement parts. First, rubber seeds is very useful properties. This is similar like linseeds and soybean oil. Rubber seed oil also could be used for the paint industry as a semi-drying oil, and in manufacture of soaps, and also production of linoleums and alkyd resins. Other than that, it also can be used for the medicines as anti-malarial oil, and engineering as a core binder for practice preparation, and the cake left after oil extraction is used in fertilizer preparation and as feed for cattle or poultry. Okay, for type of customer, there are three types of it. First is paint industry, second is soap industry, and third is petrochemical industry. For paint industry, the rubber seed is important byproducts of rubber cultivations in many tropical countries, and is often included as a component of supplement feeds to ruminants. It has a high content of semi-drying oil which may be used in the paint industry. So paint industry is one of the type of customer that is important for using seed oil, rubber seed oil. Second is soap industry. The oil which was extracted from the rubber seed using the mechanical pressing method was of high acid value. That is the free fatty acid content in high, and the oil is not edible, which an average saponification value. Its pH was slightly basic, which makes it suitable for use in soap manufacture. So it was therefore used as a substitute for palm kernel oil in the production of soaps, bar soaps and detergent soaps. Next is petrochemical industry. Rubber seed oil was extracted and its physically chemical characteristic determines. The crude oil was bleached and the ester fuel was prepared by translocation. Methyl ester yield and fuel properties of the oil and its metaster were determined and compared to that of commercial diesel fuel. The analysis of the properties compared to the commercial diesel fuel show that transmethylation improved the fuel properties of the oil. The result supports the choice of monoester in place of straight rubber seed oil. as having better potential for use as alternative diesel. Okay, next I will pass to my friend Zul Hakimi to explain more about process descriptions.
Hi, my name is Zul Hakimi bin Muhammad Nafia with ID 17591. So I'm going to continue our group's presentation with a process description of the process. Okay. Firstly, what we do is we have reagents and apparatus preparation. What actually we do is the solvent used were extract and hexane, petroleum ether, water, and a mixture of ethanol, 95% pure, and water with 70-30 ratio. And for the oil conversion to fatty acid, we have methyl ester, FAM, E, prior to alpha-linoleic acid, ALE analysis, sulfuric acid, H2SO4, toluene, and methanol were utilized. Okay, these are the reagents and apparatus that we should prepare for our experiment. Next, we do the sampling part. Sampling part is actually bulk of raw rubber, or scientific name is heavy brasilensis seeds, was dehulled manually to free kernels from its shell, and then the thin outer layer was removed from the kernels, and the clean seeds were sliced approximately in size. Okay, next we have determination of moisture content. What actually we do is the sliced seeds were divided in 3 portions, 10 grams each, and then heated in an oven with 105 degrees C for 4 hours. Okay, after the heating was done, the seeds were placed in the desiccator and weighed again. The process was repeated until constant weight was achieved. Okay, and then right after that we have solvent extraction process, where the solvent is extracted. Okay, all of the solvent that we have been using before is extracted with some of the process lah. And then we have next oil recovery using rotary evaporator. This is actually the main part of our based on our experiment, where we are using a rotary evaporator in order to do the oil recovery from the seed oil. Next, we have oil conversion to corresponding fatty acids, methyl ester, FAME. Okay, this is where the oil is converted from the raw oil, and then we converted to corresponding fatty acid, methyl ester, where it is the one that we wanted for this experiment. Okay, last but not least, we have gas chromatography mass spectrometry analysis. Okay, we do the analysis by using gas chromatography mass spectrometry machine by having some procedure that is normally used in laboratory. Alright, thank you.
Hi, I'm Shalvin Dekor. So I'll present about the process flow diagram of our rubber seed extraction. Firstly, as you can see, our process flow diagram we drew it ourselves. Since this is not available in the internet or any Google website. This is why, because our process is basically we use it in the laboratory. We don't have industry doing rubber seed extraction as a main process. This is a very small sub process. Okay, so for the first part, as you can see, this is the solvent extractor. We will put the feed into the solvent extractor. The main objective of the solvent extractor is to extract oil. Next, we will move on to the rotary evaporator, where the liquid form is used to enter the pump, and later we move on to the pre-filter. So our main component actually for research purpose is this rotary evaporator. Next, it moves on to the reactor vessel. In the reactor vessel, before we move on to the reactor vessel, we have 3 chemicals, that is toluene, H2SO4, and methanol. These 3 mixtures is mixed in a static mixture, and it moves on into the valves, where we can control how much of feed we want to move in and out, and then it goes into the reactor vessel and into the methanol recovery system. The extra methanol ethanol is not been wasted, it's been recycled and we can reuse it. The products are later moved into the separator where we only want the oil, the rubber seed oil. So the remaining is used as a waste and the rubber seed oil is collected in the oil. The rubber seed sample is later on moved into the GC machine where GC machine will analyze the sample. So as you can see, this is a very clear process of our research study regarding rubber seed extraction. Thank you.
Jaganiswaran, ID 17207. Today I'm going to present on two topics which are list of equipment and its functions and also general safety and other considerations. When we see about list of equipment, there are few units that has been used in this process. Firstly, the solvent extractor. The use of solvent extractor is to separate compound based on their relative solubilities in two different immiscible liquids, usually water and organic solvents. Then we go to rotary evaporator. Rotary evaporator is the main unit that has been used in this process. The function of rotary evaporators is for efficient removal of solvent from the sample by evaporation. Next is a pre-filter. Pre-filter, as we all know, is a filter to remove impurities. So that's all about filter. And vacuum pump. Vacuum pump is in this process it's used to remove gas molecules from sealed volume in order to leave behind a partial vacuum. And then we go to reactor vessel. Reactor vessel is a device that contain and control a chemical process in it. So then static mixer. Static mixer is a device which mix two fluids, mix two fluids or more through a tube containing series of baffles or blocks. And next is a separator. A separator in this process is used to separate gross amount of oil and suspended solid from the refineries. And a vial is used to collect a sample actually. And next is GC machine. GC machine in this process is used to analyze and identify compounds without decomposing it and test its purity of the substance. Lastly, valves. Valves is used to control the flow of fluid by opening, closing, or partially obstructing various passageways. Okay. Continue. Okay. Next, I'll move on to general safety and other considerations. As we all know, general safety is actually the most important element in any industry. It's to avoid accidents and injuries. In this case, the facility should be registered under a safety governing body to ensure all safety and legal requirements are met. And the equipments are equipped with instrumentation controls to ensure all machineries and safety alarms are working properly. The chemical solvents involved in the experiment are flammable. In this case, so no open flames must be used in the plant. And then this process does have hazards, where the chemicals involved some of them are corrosive. Therefore, all personnel and visitors are provided with goggles, masks, and gloves to avoid contact with the chemical. And if come in contact with any of this chemical, flush the exposed area for at least 15 minutes with cold water. And pipes in this plant should be insulated well, as rotary evaporator is a heat-based unit. So it is to avoid injuries for the workers. All wiring and electrical appliances are ensured to be insulated and kept away from possible injuries and injury-causing situations. And lastly, in this case, emergency or fire situation, the facility is equipped with fire protection equipment such as fire extinguisher, sprinkler system, and water hose. Okay, that's all from me. Now I'd like to pass the floor to Kimi.
Hi, meet you again. Alright. Technically, in economic analysis, we have capital investment. Capital investment is divided into two. First, fixed capital investment, and second is working capital. Fixed capital investment is more like the capital that we invest on electrical, on something with the equipment and all of the stuff. And for working capital is how we operate our plant. How much the capital investment that by operating our plant. Okay, first, a fixed capital investment is divided by few parts lah. First is estimated of purchase equipment cost. Okay. Now in our plant we did purchase vacuum pump, which is cost around 30,000, and rotary evaporator 100 liter plus, nearly 35,000, and solvent extractor 300,000, static mixer 40,000, and reactor vessel 54,000, and pre-filter approximately 10,000. So lastly is liquid separator, which is 5,000, and vial, vial 10,000, and lastly is DC machine around 7,000. So normally all the unit that we purchase is is one, except for vial we purchase around 100. So total equipment cost after we add up everything, around RM 482,000. Wow. Okay. Second thing in capital investment is equipment installation. Equipment, how much the cost that we use for installation purpose. Okay, first we do the foundation, second platforms and support, and then erection of equipment. Okay, now for the material, okay, we divided this into three percentage. First is material, labor, and the total. And lastly, for the total, after total installation, total up, we got around 207,000 and 260 ringgit Malaysia. Next, we go to piping part, which is the cost of piping covers labor, and then valves and fittings and pipe support and other terms. Okay, for complete erection of all piping used. The cost may be estimated based on amount equal to percentages of equipment value. This is based on one of the journal that I have read, which is KLM 2014. Okay, so piping around feet. These are the feet that we use. So it is somewhere. Next is instrumentation. Instrumentation is actually not only instruments, but all auxiliaries for a complete system as well. There are three parameters for which consider the cost depending on the controls installed in equipment for the purpose of a wastewater treatment plant. Only few controls are involved, so that cost may be calculated from the purchase equipment as equivalent percentage shown in the table. Okay, for example, we have material 3%, labor 1%, so total will be 4%, and then 4% times with the calculated purchase equipment cost. Okay, then we get this value 9,280. Next is electrical. Okay, so around 10% of the total equipment cost, which is equal to 48,200. Next is insulation. Since thermal evaporators, which is the rotary evaporators, are used, it is essential to consider insulation factors as the temperature of the equipment may vary from time to time. So the cost would be around 33,740 for insulation purpose. Next, we go to buildings. So technically, we have to do the building, all the plumbing part, the heating part, the ventilation, okay, the construction itself, and it costs us about 144,600 Malaysian ringgit. And then yard improvement, for sure we have to do the improvements, right? Which is cost in fencing, grading, roads, landscaping, and similar items. Some of the sort of things. Okay, it costs around 72,300. Next, service facilities. It costs you around 96,400. This is where facilities include the utilities for supplying water, power and other sources for industrial plant. Next, land. The value land is a highly fluctuating item and it depends on the location, right? So technically we just roughly estimate the land cost, which is around 4% of our equipment cost. It will be 19,280. Okay, next, engineering and supervision. Engineering and supervision is sometimes referred as a home office. Cost of contractor charges include cost of detailed design and other engineering services required to carry out project, constructing, design and engineering, drafting, purchasing, accounting, and travel, reproduction and communication, everything lah. Okay, it costs us around 120,500 ringgit. And then contractor's fee, for sure we have to pay for the contractor, right? Okay, so this costs us about 47,428.80. This is actually 4% from the direct plant cost. Okay, direct plant cost is actually coming from direct plant cost. Yeah, direct plant cost is direct cost, total direct cost, which is this one. After we have separated all the cost, the direct equipment, installation, piping and everything. Okay, as you can see there. And then contingency. Contingency charges are applied against the direct plant cost and exists to allow for variation from the cost estimate and compensate for unpredictable expenses, prices change or other similar situation. Okay, this costs you around 118,572 ringgit, which is 10% from the direct plant cost, which I have explained previously. Okay, next we have. Okay, these are the overall capital investment. Okay, after we have totaled up everything, the direct cost and the indirect cost. So the total is actually 1,472,220 ringgit at Malaysian ringgit. Okay, then let's move on to working capital. Working capital is the amount of capital required to start up, plant, finance ordinary amounts to production cost for 1 month of operation before revenues from the process start. So it costs you approximately 220,833 and 12 cents. This is actually 15% of your fixed capital investment that we have calculated before. Okay. Last but not least, okay, the total fixed capital investment we plus together with the working capital that we have calculated, final total capital investment is actually around 1,693,053 ringgit and 92 cents. Yeah, don't forget the 6% of GST. That's all.
Part which is the conclusion. So for now, Socolax extraction is a method that we use in our research study. Socolax extraction is also known as solvent extraction. It's the most efficient way to extract oil from oil seeds. So for our project, we had used rubber seed oil. The main process involves using a rotary evaporator to recover the oil, and then the element that we use in our experiment is rubber seed, which are very abundant. So rubber seed basically can be considered as a good source for human food, animal food, and even a biofuel which is high content of fat. So what we can see is the oil that for our research we use it mostly in the paint industry. We had emphasized on the paint industry and many more other sub-industries. And then the extraction of oil is very valuable. The rubber seed oil can be utilized into different industries such as cosmetic, food, oleochemical, and even petrochemical. So the conclusion based on the experiment is, we did an experiment to study the effect of pressure, rotation and concentration on the refractive index. So our experiment is divided into three parts, part A, B and C. Part A, we are studying the effect of concentration. So the final weight of the vapor decreases and the liquid weight and the refractive index increases as the concentration of NaOH increase. So for part B, we are actually studying the effect of vapor pressure. So concentration reduces the evaporation rate and causes the weight to be high. So what we concluded is, as the pressure decreases, the final weight of the vapor decreases and the liquid weight and the refractive index increases. So for the last part, we are studying the effect of rotational. So what can we know is, rotational doesn't cause any effect on the refractive index and the rate. So as we can see, the speed increases, the final weight of the liquid and vapor are roughly unaffected. That's all from me, thank you.